of the water design experts. I am Raphaele Moog, head of the water sector at the Israel Export Institute. The Israel Export Institute works in cooperation with the economic mission around the world to facilitate strategic partnership. I'm taking this opportunity to thank my colleague, Aviv Doron, head of the Economic and Trade Mission, and Elsa Sier, the Senior Trade Officer, for organizing this event with us. Today, we will introduce to you innovative water technologies for the industry. And welcome. And without further ado, Olga, if you want to mention about the questions.
Yeah, sure. Thank you for all the participants. Thank you for the trade mission to Hong Kong and for the trade mission to Taipei. We're starting our meeting, and first of all, we're also doing the record if anybody needs the after. So we're starting, and we have today four companies. It's CQM, Nufiltration, Biocastle, and ID. Each company has 10 minutes, and if it will be more than or close to 10 minutes, sorry for my, but I will be interrupting you. And we also have a Q&A session. It's in the bottom of the screen, Q&A. Please send all your questions there, and if in the end, please write what exactly company you're asking. And after the event, we will come back to these questions. We'll have a Q&A session separately. So that's why I'm asking to the Israeli companies to stay till the end of the event. Good luck to all of us. I hope this event will be interesting and also useful and fruitful. So first company is CQM. Udi and Eva, please start. Floor is yours.
Thank you very much, Olga. My name is Eva Gez. We are active. Actually, CQM has been active in Taiwan for over 20 years now, with successful installations across the region, supported by our dedicated local sales and service teams. We also have our Asia headquarters in Hong Kong that ensures a strong regional presence and seamless support to our partners and customers in the region. So I will introduce our Mr. Udi Siboni, our Chief Technology Officer for CQM, to present our technology to this field. Thank you so much. Udi, please go ahead.
We don't hear you, Udi. You are on mute. Let's share the screen.
Okay.
It's on the bottom. We see. Yeah, great.
You can see?
Yeah. Great.
But I see you in all my screen. Okay. So you can see this first slide?
Yes, we see.
Okay. So CQM work in Taiwan in some place. We in Nanya, in the Formosa refinery, and some others facility. We really like very much to enter our first step in TSMC, which we didn't yet. CQM is working all over the world with many of semiconductor facility like Samsung and others. And I want to start show my slide very quick. I don't move. The sharing. You can see the next slide.
Yes, we see.
Okay, we work also with power plant, with treat wastewater water that using in cooling tower, in refinery, in China and other country. We work with many places and many facility like car company and data center and all over the world from the corner of Chile to Europe and Hong Kong and China and Japan and Korea. CQM basically have two technology. One technology is the electrolyte system that we use for drinking water, wastewater disinfection, and we use it in hot water against Legionella or cold water and closed cycles treatment when we have bacteria. We also have the ATCS, the automatic tube cleaning system that we use in petrochemical, refinery, and semiconductor, data center, AC. When we use our electrolysis system, it means that we work with no chemical and we treat the water and keep the condition on the water, and also we save water and save chemical. And when we work with the ADCS, which I come back to it, we save a lot of energy. We managed to work with the electrolyte system because we have a automatic cleaning system that keeps the cathode clean constantly from the scale and other materials that connect to the cathode. This is automatic rotated. I don't show you the movie because I want to succeed to finish the 10 minutes and show you everything. But you can see it turning and all the scale falling down. We also save a lot of water and by increasing the conductivity in the cooling tower. If you look at the water, you can see the filling in cooling tower without our system. Even with the use of chemicals, they suffer with bacteria and suffer from corrosion and suffer from scale. And with our system, we solve this issue. So this can be in cooling tower or in wastewater in semiconductor, which we have sometimes heavy metal and other when they wash the component. Also, we have a few model, and we also can combine all the model together to get a much bigger capacity to treat a very, very huge plant. You can see in the other slide a project we did with a biofuel factory that using biologic component to add to the fuel to make it better green, and all the system are controlled by PLC, which we can monitor and follow the data and changing stuff, all security, and very, very with huge and very good results. When we work in a big facility like power plant, the saving is dramatic because it's very huge system. They save chemicals, they save water, and what's more is they make a bigger amount of kilowatt producing. Just a minute, back. if you, why is it going like this? Sorry. Okay, when we talk about the automatic tube cleaning system, in a refinery, in power plant, in other, the tubes suffer from scale, and especially when you work with wastewater and bacteria, and with our bowls, we can keep it clean. We have a special bowls, not like all the other company. We also have a silicone bowls that with special shapes that can keep it clean and stay for very, very long time, more than a few years. And we don't lose balls. We don't need to count the balls. Every company that buy one system continue to buy more and more and more systems. The best way to get this result is by injection all the balls together to the inlet of the heat exchangers. Then cloud of balls pass in the tubes, and the ball slightly bigger than the tube, and they keep the tubes all the time cleaning. You can see our installation in many places, in a data center, semiconductor, in the cigarette company, in power plant. You can see the size of the ball trap, how big, and also you can see the size of ball trap that feed the chiller for 2000 TR and more. We have many installation in power plant. We have many installation in factory like with chillers, and usually the payback of the system is sometimes less than 1 year if it's factory, and if it's AC is a year and a half. That's about it. If you have a question and later you want to get some more data regarding special application, we can send you and contact with you.
Thank you a lot, Udi. Please write the questions once you will have it, and we will proceed with these questions. And I need to say that anyway, we will send all the contacts of the Israeli companies to ELSA, to the trade mission, and we will be in the contact after for sure. So
Thank you.
Thank you a lot. And now we are going to the Nufiltration company. Lior, could you please start? 10 minutes.
Thank you, Olga. Hello for everybody. You hear me well?
Yes, we hear you.
Okay, my name is Lior Kohler. I'm sales manager for Nufiltration. I'm more than 30 years already in water treatment sector, and working in many technology like filter, desalination, and etc. And now I'm going to share in my presentation about Nuf, and we are talking now a very unique technology. Okay, we have it's a Israeli company. We have a patent for our technology, and let's moving for presentation.
So we see it's a preview.
So working?
It's a preview mode, but we see.
Okay, but okay. I don't know why. For me, I want in full screen. Okay, but you see the slide is moving.
No, it's the first slide. We see just the first one in the preview mode. It's not the presentation mode.
I don't know why it's not moving.
Now not.
Yeah, but not in the.
Now it moved.
I don't know. I want. Somebody know why it's not moving if in presentation mode. I need to move. Let me see.
Gabi, could you please suggest?
You can continue talking, just move it along as it is.
Yeah, but I don't know it, but it's not moving for you in a full screen.
Please change the slide.
Now I changed the slide. I changed it.
No. Put your mouse on the second one on the left side of the screen. No, it's
You might have another screen open for some reason, and we're seeing the other screen.
Let's see.
And now it's moving. Now I will see it.
Yeah, but it's look like a preview mode. Oh.
Yes, exactly.
Okay, let's go in preview mode. Okay,
great. Thank you.
No time. I'll check it later. What is the technical problem? Okay, what is Nuf? Nuf, first of all, it's new ultrafiltration. Ultrafiltration, probably all of you know, but this traditional technology. But the problem, usually you find the ultrafiltration only in industrial, like semiconductor, pharmaceutical, food and beverage, etc. This is the tradition of, and what is mean. And we take this technology. It's a very, very high level. Sorry, of filtration technology for water treatment and wastewater treatment, and we take this technology and make it informable and how it's working. Okay. This also we can see it here in my hands. I hope so we can see it. Okay. This is membrane. It's the original use is dialysis. It means artificial kidney. It means everyone has problem with the kidney. They go to the hospital or some dialysis center. You need to connect to the machine in his blood. It's making this membrane, make it filter and make it take it all this infection out of the blood, and they get back clean blood to his body. Like you see, usually it's dynamic, but because it's preview, I can show it. But I hope so you understand. Okay. So far, we don't talk about we talk about medical device. We don't talk yet about water treatment. But what is the problem? The problem is, in average, everyone, sorry, did this process, need to go to the hospital 3 times a week. And in the end, we talk about huge number of something like 2,500,000 part all over the world. It's a huge number. Only Israel, we talk about something like million parts. And the problem, it's a big damage for the environmental and also for the aquifer, for the water, because like you see in my hands, okay, it's a plastic nylon and a fiber. It's not gone away. It's left. When you left it, it's in the can be on the with our garbage from home, environmental. And there's a 2 option, and it's after 1 use, there's a 2 option. Option A is going to the medical waste. Okay, it's something like 95%. It's go this way. Also, Israel, the most of the world. And option B, one professor from Israel, the Israeli people here know him very well after the corona. It's called Yoram Lass. Is find a special process that cleaning and sanitation this membrane after 1 use and return to the original use. But what is the problem? Only for the same patient. In the end, this huge number of 250 million parts every year of the world, it's going to the medical waste, damage to our environmental and for the water. But Yoram Lass, this professor of Israel, say, okay, this good process to use again this membrane for human being. Let's take this process and use it for water treatment. And for this process we have a patent. It means our patent. We are take this membrane from the hospital to make in our factory, the cleaning sanitation, and we are manufacture a water treatment filter and systems. That's how it's working. After we make the sanitation and cleaning, that's how it's working. What is meaning inside out. Okay, you are using the whole part of the membrane. Okay, and you have complete clean, and then we talk about very high level of filter grade at 0.03 micron absolute. And what it means, if you take this filtration spectrum, we can see we have even better of the ultrafiltration, the traditional ultrafiltration, because if 0.03 is the absolute, but the nominal filter grade is 0.003. It means we are remove not only the particle, we remove the all pathogen, even virus and organic matter. It means we not only filter in single pass, mechanical pass, we make both disinfection and filter without any chemical on the process. Some detail of the membrane, but let's move it. Let's see the whole vision of the company from when we start the company. The company is registered in 2011. Where we are complete commercial company from 2016. It's been almost 10 years already on the market, and we sell more than 1,000 systems all over the world. And we have some main sector we are working. First of all, we are not make a deal, like I start to say, in our vision, we don't make a deal with separate membrane. Okay, the whole idea, the whole vision of the company is to design and manufacture a standard system, which then include some membrane, include the capacity and the application in parallel. Okay, because for example, one membrane, it's something we can treat something at 100 liters per hour, but the basic system we are start of a parallel of a module of 40 membrane. It means something it's working for 5 cubic meter per hour in average. The main sector we are working, you can see here on this slide, we are working in agriculture, especially of reusing water from greenhouses, effluent, that we are talking more deeply because this is the issue of this webinar. Swimming pool, industrial, and drinking water, both for routine and humanitarian in emergency. How it's working in effluent. Again, we are not making, it's very important to say, we are not making the full of a facility of wastewater. Okay, we are doing only the polish. Okay, it's very important to say it. Okay, we are coming after the treatment, after the first and the second. We are the third treatment. I don't know who is here knowing. In Israel, we use wastewater, something like 90%. We use again for agriculture. And this is the reason we start in Israel. Also, we have the specially informed from the Israel authority to use it for use again in agriculture. How it's working? Okay. Like I say, we don't take the first and the second treatment. We come in after. Okay. After the secondary effluent, we take the water through the Nuf to the outer membrane, and the pathogen, the organic matter going out, removing 100%, and you have a clean water. This water even you can drink it, this water, because it's very clean. But the problem, it's the authority rules each one. But it's very good for agriculture, for irrigation, for greenhouses, open file, etc. Everything. What we call in class A, class 1, or class A. You can see what is the effluent water we can handle. Of course, we don't take everything. Like I say, we are coming after the secondary effluent.
Leor, you have just 1 minute left. Thank you.
Only one?
Yeah.
Oh, okay. Okay, then. Okay, this is what you get after the Nuf. You see very, very good result. Okay. Let's go. So for some, of course, we can use it for agriculture, for cooling tower, other using. Let's take some example. This example in Mitzar, this is north of Israel in Golan Mountains. We are very proud of this system, one of the big we have all over the world. It's also in Israel, Yagur. Now we're going to do upgrade for this system these days. This is in Peru, another system for 40 cubic meter per hour. And we are also working in Veolia in France, in south of France. See, for example, what kind of water you can see in a visual and also in turbidity measure. What we have of the effluent, and we have the treatment, and of course we have the backwash, and you can see 3 color of water. Okay, I try to finish in time, so it's okay.
Great, thank you. Right on time, actually. Thank you, Lior. I want to remind again about questions, so you can put them.
You collect the question for the whole company, and
for all the companies, I don't see them for now, but
Okay.
I hope that will be later on.
Okay.
So
Thank you very much.
Thank you, Lior. So now is a Biocastle company. Gabi, can you please share?
Hello, good morning. Before I share my screen, just like to show you something in short. So my name is Gabi Wilkinson, and I'm the CEO of Biocastle, and this is our technology. What you're looking at here is maybe the smallest bioreactor you've ever seen. That's what it is. It's a bioreactor. We do biological treatment. And now I'm going to show you how we do it and what is so special about this technology. Let me just share the screen. Okay, so what we're looking at is a capsule, the size that you saw, which is a 3D membrane. The capsule is a membrane where the bacteria that usually we grow in our ponds, whether it be oxidated sludge or an MBBR, the bacteria here is grown inside the capsule. So you can see it here in large, how we have the capsule, and we have the bacteria inside the capsule, and very small pores that do not allow the bacteria to get out of the capsule. The bacteria outside of the capsule will not penetrate. Only the water with contaminants will go into the capsule and be treated by the bacteria inside. So this allows us 3 elements of control that usually you will not have in any bioreactor. We can define the type of bacteria we want to implement in our system. We can define the amount of bacteria we want in our system, and we can define the place of the bacteria in our system. By defining these 3 elements, we can control the bacteria inside the wastewater treatment system, which allows us to bring different types of treatments that you cannot do in other ways. In a moment, I'm going to talk about the applications, but before, I want to explain that the revolution here is extreme, because if until now we were talking about taking the water body and trafficking it through the treatment media, in our case, we do not need to traffic the water through the treatment media. What we need to do is to traffic the contaminants into the treatment media. So it's only the contaminants moving, and you are saving a lot of effort in doing so. How do the contaminants get into the capsule? We don't have to push them in. you have to imagine how the hosting water body, which is your treatment system, will host the capsule, which is inside the main water body. So you have two water bodies separated by a membrane, which means that the water inside of the capsule and the water outside need to be the same. And once the bacteria inside the capsule treats the contaminants, then you need to make it equivalent. And so there is automatic diffusion of contaminants into the capsules. And what we have here are actual contaminant pumps, which are pumping into the capsule the contaminants all the time. This means we can actually take a water body, and it could be a sedimentation water body or whatever, and turn it into a treatment reservoir. Take a look at this video here. What you can see here is 700,000 cubic meters of water per year, effluent water. And we were asked to do a nitrification process. You can see 5 cages here, which have different types of capsules, the nitrification capsules and the denitrification capsules, which are all working at the same time in the pond. And this actually reduced the investments by millions, because instead of needing to take the water out of the pond, treat it, and send it back, all we needed to do is to add the capsules into the water and turn the pond into a treatment pond. In this way, we can reduce investments in wastewater treatment facilities. We can reduce the cost of operation. Also, the activities of the operation are reduced, because all we need to do is once a month, we come to the treatment pond and we'll add new capsules. The old capsules will break down into sugar and leave no fingerprint in the water. So we are 100% sustainable. Very, very, very simple. So as I said before, and I'll go over it again, what we are introducing here is an opportunity to take to do what we call bioaugmentation, to bring the bacteria from the outside and implement it into the pond. But it's not like the ordinary bioaugmentation you're used to, where you take the chemicals and throw it into the water and they go downstream and you have to continue dosing. We're talking about a bioreactor within your big bioreactor. We can put the capsules in the right location, next to the diffusers if we want it, in an aerated tank, away from the oxygen if we want to get an anoxic treatment. We can put the exact type of bacteria that we need in order to treat your specific contaminant. We can choose your bacteria and implement it into our capsules. We don't even need to know what bacteria it is. And it can be implemented and treat the specific contaminant you have and dose it in the amount that you need in order to treat your pond. It's all of a half an hour of work once a month to add the capsules into the water. You can leave the capsules on the shelf for years. We have a lot of experience both in the sanitary wastewater treatment systems and a lot of industrial wastewater treatment systems, specifically food and beverage, which is all organic. We have a lot of experience also in pharma and in agriculture. And it's good for any place where you want to do biological treatment. So we're working both in Israel and outside of Israel, in the United States and South America. We are working in India and soon probably in China. We do have a few patents and some pending, many peer-reviewed articles, and a lot of cooperation both in the academic world and with daughter companies, one in the aquaculture industry and one in ground treatment, soil treatment. I think that's it. That's the main stuff. Happy to answer questions if you need.
Great. Thank you, Gabi. I see two questions, one for you and one for Nufiltration. So we will come back to them later on at the end of the. Once we have 1 minute, can you please reply? Question for Biocastle, maybe you see it. In the solution available for TOC reduction, what will be the performance of the solution compared with UV TOC reduction?
We don't come instead of a UV.
We don't hear you, unfortunately.
Can you hear me now?
Yes, now yes.
Okay, we don't come instead of UV. We don't do disinfection. So we're a biological treatment. However, if you want to treat the biological contaminants together with your UV system, you will get extraordinary results because we don't need the UV will not affect the bacteria inside the capsule, which means that you can biodegrade your contaminants much easier. And also, you only need one chamber for them both. You do not need to traffic the water from one tank to the other and separate your disinfection and the biological treatment.
Also, the next question is either limit of the range of MLSS.
Yeah. So, first of all, we don't have any waste sludge from our treatment. And many times also we'll see a reduction in the amount of waste sludge as a result of using the capsules. But everything depends also on the amount of treatment that we need, the amount of contaminants. I would not talk about any limits to anything.
Okay.
Until we see the data.
Okay, understood. It's logical. Thank you. Thank you, Gabi. So now we're going to the last company, ID. Roy?
Yes.
Can
Hello.
you please start with the presentation? We see, but it's a preview mode.
Still a preview mode?
No, it's presentation mode.
Okay, excellent. Thank you very much. Thank you for having me. I'm going to talk today about the semiconductor industry and water solutions for sustainable water management. My name is Roy Zaken Porat. I'm Director of Water Treatment with IDE. I'm going to start with a short introduction of IDE, and then I'm going to speak a little bit about the semiconductor fab water treatment and IDE, recovery reverse osmosis solutions for this industry, a little bit about PFAS, and I'm going to conclude and summarize. So starting with IDE, IDE is a company that's been around since the 1960s. It's a technology leader in water treatment for many, many years. We have more than 600 installations, and when I say installations, I mean plants, water treatment plants, big ones, in over 40 countries. We're headquartered in Israel, but we have offices in the US, India, Chile, and Australia, design offices as well. What we do actually is a wide range of water treatment solutions. We have our desalination sector, mainly the mega-sized plants. In Taiwan, we are actually commissioning one very big one in Formosa facility of 100,000 cubic meters per day water treatment. We have our industrial sector that we're going to discuss a little today with the high recovery solutions that I'm going to mention. And we have also wastewater reuse applications that we actually offer. In terms of presence and plants, I just wanted to show you some of the, we actually have the biggest desalination plants in a lot of places around the world, such as the US, in California, 204,000 cubic meters per day, or Reliance, India, 400,000 cubic meters per day. You see others here, and very, very big BOT plants in Israel. So this is about ID in general. Our approach when we bring solutions to our client is a modular approach. We have prefabricated offsite manufacturing capabilities in almost all of our water treatment plants, which reduce the engineering hours and the construction schedule and helps a lot to the EPC contractors we work with on these specific plants. Now, with that introduction, I want to focus a little bit on the semiconductor industry. I want to mention by saying that IDE treats water in a lot of sectors. It can be any industry you can think of, but today I'm going to focus on the semiconductor industry. And I'm going to start with maybe mentioning a little bit about the semiconductor industry and where IDE fits in. So in the semiconductor industry, there are three main sections of water treatment, I would say. There is the ultra pure section that actually gets water from the grid and needs to be treated to ultra pure quality, so it can be used in the wafer production process. So this is one type of water. The other type is all the waste that is coming from all of the production processes. We see a list of them here. These are the special treatments. So you have for each one of them, such as the HFW and CMPs and so on. Some of them you will see in all of the fabs. Some of them are unique. The grinding and dicing, for example, will not happen in each fab, and so on. But generally, most of these tools will have point of use abandonment treatment systems, but then everything will be taken out as wastewater. So each line here that you see coming out is a stream. IDE is actually treating each and every one and has solutions, water treatment solutions for each and every one of them. At the end, everything reaches to a neutralization tank or pond. And then we have the water coming out. This is the end of pipe water. Now, a lot of time, this will be treated by a biological treatment, MBR or so, and then discharged maybe to the municipality. But these days, and we're going to speak about it, because of contaminants, because of water scarcity, a lot of companies are looking to ZLD solutions, and here also IDE comes in with its unique solutions of high recovery reverse osmosis and a complete package for this ZLD treatment. Now, what are the water challenges and how does IDE give a solution to them? So in terms of water challenges, first of all, we have water scarcity. Water demand is high, mainly for a fab, and this is why the limitation in water available from the municipality is increasing. Another thing is regulation. I mean, there's a lot of contaminants in wastewater from industries and in the semiconductor as well, such as PFAS, such as others, so regulations in place. And others is environmental commitments, corporate goals for water conversation. And this is why companies are looking to maximize internal reclaim, minimize the disposal, and optimize their brine management. And this is why wastewater reclaim is a must these days. And this is where IDE comes with its unique proprietary technologies. We have two solutions that we call them the Max H2O solutions. One is called pulse flow reverse osmosis that helps overcome typical RO challenges, scaling, fouling, and so on. And the other one is the Max H2O desalter, which actually allows to reach a very, very, very high water recovery and reclaim. Both technologies are validated by FTD Solutions, and I want to speak briefly about them. The first one, the pulse flow reverse osmosis, is a technology that actually changes the hydraulic of reverse osmosis system. In conventional system, as you see in the graph above, you have constant flow of permeate and constant flow of brine. This is a standard reverse osmosis unit. What it does cause, these constant conditions, is actually a great atmosphere for bacteria to grow biofouling, for fouling to happen, for scaling to happen, because you reach very high concentrations of constituents at the last membrane. Now, IDE actually developed a unique technology that works in a cyclic operation, production mode and flushing mode. So you see the graph at the bottom. You have production and production of permeate constantly, but you have only limited amount of time in which brine is ejected out and washes the membrane and changes the salinity. This allows us to work at very, very high recoveries with no scaling or fouling. This is something that was implemented in various plants. I can tell you about a FAB. Of course, I cannot mention the company, but I can mention a FAB that we actually fitted it in and put it in parallel to an existing standard reverse osmosis unit that was able to work only, the standard one, at 30% recovery with a lot of CIPs, a monthly CIP. This system worked continuously and still working continuously for 3 years now with CIP once a year and with much higher recovery, double the recovery of the standard one. So this is one technology. I'll be happy to show you some case studies if there are any answers later. The other technology is the Max H2O desalter, which allows to reach very, very high recovery, which means that we overcome any scale that might happen by precipitating it out in a fluidized bed reactor. This is again a patent of IDE that we actually developed with a Dutch company, Royal Haskoning DHV. It's actually a reverse osmosis in which the brine that is oversaturated with salts such as silica, calcium fluoride, calcium carbonate, calcium sulfate is transferred to a fluidized bed reactor in which the solids, the scaling solids precipitate on the seeds in the fluidized bed reactor, and then the brine without those scaling constituents is transferred back to the feed tank, and again the process continues and we can reach like 90, even 99% recovery of water, 99% reclaim of good water that can be used for various applications within the FAB, minimizing the amount of water you take from the grid. So
Roy, sorry
yes,
for interrupting you. You have just 1 minute left.
this
Thank
is
you.
exactly what I need. Thank you.
Thank you.
So in terms of when we look at that, and we look at the end of pipe as an example, if we take water such as 100 GPM coming in, and we're trying to retreat it with standard reverse osmosis, we will reach 50 and 60% recovery and very high scaling and fouling. The industry found a solution in the high pH RO, but this is very chemical intense and solution that can give you 90%, but the desalter in 1.1 time can bring you the same solution, lower chemical power and footprint and carbon emissions. In terms of PFAS, IDE is familiar with all of the treatment solutions and can treat the PFAS for our clients, and end of pipe can be end of PFAS. So this is another thing that we do, and we integrate and we work together with the companies that needs these solutions. So we can integrate GAC, ion exchange, and high recovery reverse osmosis. And to summarize, circular water economy is a must. This means that water reclaim is a must, and IDE, PFRO, and desalter actually increase the recovery of membrane processes, does increase the reclaim within the semiconductor industry. This high recovery technologies is a great fit for the semiconductor, but also for many other industries, such as the cooling tower blowdown in many facilities and other water treatment reclaim needs. And it brings a really cost-effective solution also for water treatment. And thank you very much.
Thank you a lot, Roy. And we have also already the question for you. I believe it's for you. What the benefit for PFRO with the comparison of FRRO and CCRO? Do you see the question?
Yes, most certainly. I can see it. Okay, so CCRO is indeed the technology by the Salitech and DuPont. And in a sense, this is a comparable technology. However, with the CCRO, there is a circulation pump that is added and another tank that is added. And in addition, in CCRO, there is continuous work at high salinity before you eject the water. The PFRO actually comes to solve this. PFRO actually works in terms of scaling in the induction time zone with only one stage of membranes, without any additional pumps, without any additional tanks. At the at the induction time zone in scaling. Let me explain this. When we talk about scaling creation, and this is what we're coming to prevent, right? At the end, these high recovery solutions are aimed at minimizing the scaling, fouling, and biofouling. Now, when a crystal is formed, it starts with some supersaturation of scaling salts. It has the nucleation stage, in which, according to Gibbs law, of course, you need this critical size of a particle or a crystal to form, and then you have crystallization upon the membranes. In the PFRO, we don't allow this. All the time, we have high saturation, then we flush, reduce it back to the induction time, and this is the big advantage. So we have the advantage of the equipment that is much less. We have the advantage of the induction time, and in a sense, these both technologies are comparable in the offering of the end product, but essentially the PFRO is much more easier to use and beneficial in terms of scaling than the CCRO.
Great, thank you a lot. Thank you a lot. And we have the last question for Nufiltration. Lior, are you here? Can you please reply?
Of course, I'm here.
Do you see the question? If I buy a hollow fiber from you, will you suggest how to configure the system? What is the membrane? What about hollow fiber? How much the flux rate? So three questions actually.
Okay. About the first one, of course, we help you for configuration. When you must send us the details about the feed water and what is your expect for the product, and of course the flow and all details. We are request for making the engineering process and the quotation. But of course, we are doing this configuration together. We have for you. Like again, we are not selling the membrane separate. We are selling systems. It's very important to say. About the other question, you see here in the datasheet, you see my screen?
Yes, we see.
Okay, and you see exactly what is the filtration area. We are talking about between, because we have usually it's a 2 square meter, because it's between 1.8 to 2, because in the past we are used of 2 model of this membrane. Okay, and about the flux, you can see also we're talking about between 60 to 80 liter per hour to a square meter. But again, this is for separate membrane. In the end, you don't buy membrane, you buy for us the system, the complete solution.
Great. Thank you a lot, Lior. I think it's clear. And we received a new question for Biocastle. Gabi, are you here yet?
Yes, I'm still here.
Great. The last minutes before leaving.
Yeah.
So it's suitable for low FM domestic sewage, because often encounter the problem of insufficient carbon sources.
Yes, so when you have insufficient carbon sources, so you need to add a carbon source, obviously. Most specifically, when we're talking about denitrification, where you need a carbon source within the anoxic system. And so what we did, for instance, in the video that I showed, is we took another pond that was in the area, has the same effluent, and has the carbon source inside. So we took a stream, a very small like hose, to bring the carbon source directly towards the bring the carbon source towards the capsules and to feed the bacteria. So we can save a lot of money on that. So if you need a carbon source, usually you bring it from the outside. This way we can do it much in a reduced level. Very, very significant. I hope I answered the question. Also, I answered the 2 other questions on the Q&A session here. I wrote them down for whoever wrote them so that they can see.
Okay, great. Thank you a lot, Gabi. I see that it's all the questions that we have for today. And I want to thank you to all the companies that participated. Okay. We received the new one. Can I have the contact information? For sure. I want to say that we will send all the information about the companies, all the contacts to Elsa, and then you can proceed and you can contact her if you have some questions, if you want to meet again. So it will be great for sure. We are very open. And now we're about to finalizing our event. Do anybody wants to say something, Elsa?
I want to say thank you again for this very interesting session for all the company, and hope this will give you information on the potential. Of course, we have many other companies in different other sectors of that can be relevant. Thank you.
Yeah, I would like to say some word in Chinese. Sorry.
Great.
我看到有一些报名的公司，你们有挑选几家以色列公司，想要会后跟他们做 B to B。那我会在个别跟大家电话联络，那看看你们是不是在听完今天这一次的简报之后，对他们还是想要有安排 B to B 的会议。那我如果还有的话，我们就再进一步安排跟这些厂商的 B to B 会议这样子。那我会在个别跟大家联络，谢谢。谢谢今天的参与 ，Thank you.
Thank you, Elsa. I believe I understand about what B2B, and
Yes.
So great. Thank you a lot.
Yes.
So
Okay.
so we had a recording also. So we will send the recording after. Thank you a lot.